We are discussing GATE Physics 2014 Quantum Mechanics problem. This is 1 marks MCQ and the statement of problem is the recoil momentum of an electron is Pa when it emits a photon of wavelength 1500 nanometer and it is Pb when it emits a photon of visible wavelength 500 nanometer. The ratio of Pa by Pb is. Solution. According to de Broglie hypothesis, lambda is equals to h by p implies p is equals to h by lambda. So the ratio of Pa by Pb is equals to h by lambda a divided by h, and lambda b is equals to lambda b by lambda a, which is equals to 500 nanometer divided by 1500 nanometer is equals to 1 by 3. Thus, our answer for this problem is option C, 1 by 3. The ground state and first excited state wave function of a one-dimension infinite potential velar of psi1 and psi2 respectively. When two spin-up electrons are placed in this potential, which one of the following with x1 and x2 denoting the position of the two electrons correctly represent the state part of ground state wave function of the system? So we have to determine the ground state wave function. Solution. According to Pauli's exclusion principle, the total wave function ब्रैकेट में spin part into space part must be antisymmetric. Since the spin part is symmetric, that is, particle is having upspin, the space part wave function or spatial, we can write it spatial wave function must be antisymmetric. Thus, option D, in which The option D is the correct answer, where space part is antimatter. Thus, option D is correct answer. Let us read the statement of this question. Which one of the following is a fermion? Solution: alpha particle 2 plus 2 neutron, that is spin is even, particle is boson. 7 Be4 implies 4p plus 3 neutron, spin is odd, particle is fermion. H atom 1p plus 1n, so particle is boson. Deuterium 1p plus 1n, spin is even, particle is boson. Here odd refers to half integer, means you just place 1 by 2 spin, so that will be 2 and that will be 3 by 2. 2 plus 3 by 2, 5 by 2. 5 by 2 spin would be for fermion. Here you would be having it 1 plus 1, 2, so 2 would be for boson. Here you would bring half plus half 1 for boson and 1 half plus half 1 for boson. So you can write it down. Spin would be, it is 2, it is 2 plus 3 by 2, that is 5 by 2. Spin would be 1, spin would be 1, so we can check it off. Half integer spin is only for this, and that means our beryllium is fermion. If L is the orbital angular momentum, S is the spin angular momentum, then Ls does not commute with which of the following options? The total solution, the total angular momentum is given by J is equals to L plus S implies J square is equals to L square plus S square plus 2 L dot S implies L dot S is equals to one by 2 of J square minus L square minus S square. Thus, L dot S will commute with all terms of J but not as Z, that is L dot S J square L dot S L square L dot S S square equals to 0, but L dot S comma S share it does not equals to 0. So thus our answer is option A. An electron in the grounded state of hydrogen atom has a wave function psi r is equals to this, where A naught is constant, the expectation value of the operator Q square, where Z is equals to R cos theta is. We have to determine the value of this. Solution: we have psi is equals to 1 by root pi aq e की power minus r by a0 q square is equals to z square minus r square, where z is equals to r cos theta. So the expectation value of operator q is given by q is equals to q z square minus r square a0 square minus 3a0 square, that is minus 2a0 square, where we have used expectation value of z square would be small psi square cos square theta into d tau, which can be written as 1 by pi a0 cube 0 to infinity r to the power 4 e to the power minus 2 r by a0 dr 0 to pi cos square theta sin theta d theta and 0 to 2 pi d phi. So this value will give us 4 pi upon 3 pi a naught cube 0 to infinity e की power minus 2 r by a0 r to the power 4 dr, which is coming out equals to a0 r square. Further, and expectation of r square would be expectation of x square plus y square plus z square, that is coming out to be expectation of x square plus expectation of y square plus expectation of z square, which is equals to 3a0 square. Thus, our correct option is minus D, minus 2a square, that is option D. A particle is confined to a one-dimensional potential box with potential this. If a particle is subjected to perturbation within a box stated W is equals to beta x, where beta is a small constant, the first order correction to the ground stage is. Solution: we have v of x is equals to, or v dash x is equals to beta x, that is perturbed Hamiltonian. The first order correction to the ground state energy is given by, that is E1 would be psi 1 v dash psi 1, which is equals to 0 to a 2 by a sin square pi x by a beta x dx, which is equals to beta 2 by a into a square by 4, which is turning out to beta a by 2, where psi 1 for particle in a one box is defined as 2 by a sin pi x by a. Thus, our answer is option C. A particle of mass m is subjected to the potential Vxy half m omega square x square plus y square. The state with energy 4h cross omega g-fold degenerate. The value of g is. Solution: we have Vxy is equals to half m omega square x square plus y square. The energy of the particle confined in this potential is given by E nx and y is equals to nx plus ny plus 1 h cross omega, which is equals to n plus 1 into h cross omega, which is equals to 4h cross omega, implies n is equals to 3, where we have used n is equals to nx plus ny. The degeneracy in the energy for 2D harmonic oscillator is given by Gn is equals to n plus 1, that is 3 plus 1 equals to 4. So degeneracy, the value of G is 4. A hydrogen atom is in the state psi is equals to 8 by 21, psi 20 minus 3 by 7, psi 310 plus 4 by 21, psi 321, and where NLM and SINOD denote the principal orbital magnetic quantum number respectively. If L is the angular momentum, the value of L square is. Solution. We have state psi is equals to root 8 by 21 psi 200 minus 3 by 7 psi 310 plus 4 by 21 root psi 321 and mod psi over psi is equals to 8 by 21 psi 200 psi 200 plus 3 by 7 psi 310 psi 310 plus 4 by 21 psi 321 psi 321 give us 8 by 21 plus 9 by 21 plus 4 by 21 equals to 1, that is psi is normalized. So the expectation average L square is given by average L square is equals to psi L square mod psi, which is equals to 8 by 21 average psi 200 L square psi 200 plus 3 by 7 psi 310 L square psi 310 plus 4 by 21 psi 321 L square psi 321, which is equals to 0 plus 6 by 7 h cross square plus 8 by 7 h cross square equals to 2h cross square, where we have used psi L square psi equals to L into L plus 1 H cross square, that is psi 200 into L square psi 200 is equals to 0 psi 310 L square psi 310 is equals to 2 H cross square, and psi 21 L square psi 321 is equals to 6 H cross square. So thus our option for this problem would be numerical value is 2. Psi 1 and psi 2 are the two orthogonal states of spin half system. It is given that psi 1 is in this state where 1 0 and 0 1 represent spin up and spin down state. When the system is in state psi 2, its probability to be in the spin up state is. So we have to determine what is the value of psi 2. Solution. We have psi 1 is equals to 1 by root 3 1 0 plus 2 by 3 0 1, which can be written as 1 by root 3 state phi 1 plus 2 by 3 state phi 2, where we have defined phi 1 as 1, 0 and phi 2 as 0, 1. So let us define the orthogonal state psi 2 as psi 2 is equals to A phi 1 plus B phi 2. Since psi 1 is orthogonal to state psi 2, we have psi 1 psi 2 is equals to 0 implies A by 1 by root 3 phi 1 plus B by root 3 equals to phi 2 dot phi 2 equals to 0 implies B is equals to minus A 1 by root 2. Thus our psi 2 takes the form that is equals to A of phi 1 minus A by root 2 of phi 2. Applying normalization condition psi 2 dot psi 2, we get A square phi 1 plus A square by 2 phi 2 equals to 1 implies A equals to root 2 by 3. So the normalized psi psi 2 is given by mod psi 2 is equals to root 2 by 3 of phi 1 plus minus 1 by root 3 of phi 2. The probability ability of finding particle in spin-up state is that is P of phi 1 equals to phi 1 dot psi 2 mod square would be equals to root 2 by 3 phi 1 square, that is 2 by 3. So our answer is 2 by 3. That is nearly about 0.66. A one-dimension harmonic oscillator is in a superposition of a number state n given by psi is equals to 1 by 2 of 2 and 3 by 2 of 3. The average energy of the oscillator in this given state is solution. We have psi is equals to 1 by 2, 2 plus root 3 by 2 of 3, and also psi by psi is equals to 1 by 4, 2 of 2 plus 3 by 4, 3 of 3 is equals to 1. Now, the average energy of oscillator is given by average E is equals to psi h psi, which gives us 1 by 4, 2 of h of 2 plus 3 by 4, 3 h of 3, which is turning out to be 1 by 4 E2 plus 3 by 4 E3, and this, if we calculate 1 by 4 into 5 by 2 h cross omega plus 3 by 4 into 7 by 2 h cross omega, that is 13 by 4 h cut omega, where we have used E2 is equals to 5 by 2 h cut omega and E3 is equals to 7 by 2 h cut omega, and here I can write En is equals to n plus half h cut omega. So thus our numerical value would be 13 by 4. If L plus and L minus are the angular momentum ladder operator, then the expectation value of L plus L minus L plus in the state L1 M1 of an atom is. So let us determine what is the value of L plus L minus. Solution. We have now L plus is defined as Lx plus ILy, and L minus is defined as Lx minus ILy. ठीक है. Now the value of L plus and L minus is given by L plus to L minus is equals to Lx plus ILy to Lx minus ILy is equals to Lx square plus Ly square plus ILy Lx minus Lx Ly. This term can be written as L square minus Lz square minus I Lx Ly minus Ly Lx further modified as L square minus Lz square minus I into Lx Ly का commutator, and this can be further written as L square minus Lz square minus I. Lx Ly is I h cross Lz, which can be written as L square minus Lz square plus h cross Lz. Similarly, if we determine the value of L minus L plus, we get L minus L plus is equals to L square minus Lz square minus h cross Lz. Thus, the expectation value of L plus L minus into L plus is L plus into L minus plus L into L plus for L is equals to 1 and M is equals to 1 is equals to twice expectation value of L square minus Lz square. L is equals to 1, M is equals to 1, which can be written as 2h cross square into L plus 1 minus M L square. So, or simply write it M here, M square, which can be equals to 2h square to 1 into 1 plus 1 minus 1 square, which is turning up to be 2h cut square. So, our numerical value for this question is 2.